This video is on heat. While you're watching this video, you should have your notes out, ready to fill in. Also, you will have questions to answer throughout the video that will count as a grade as well. So heat. First thing we need to talk about is what is it? So what is heat? Heat is the transfer of thermal energy from one object to another because of temperature differences. So how does it transfer? That's the next question. How does it transfer? It always goes from the warm temperature to the cold temperature. So it always goes from the warm object to the cold object. That's why we associate heat as being hot, because if you're cold and you go and touch something that has a warmer temperature than you, the heat is going from the warm object to your hand. Okay? Heat does not necessarily mean that it's hot, because hot is a perspective. It's what you think is hot. It might not be hot to somebody else. Okay? So if it's going from the warm object to the cold object, it's heat. So what is temperature? A lot of times these words are used as if they're the exact same thing, but they're not. Okay? So heat is the transfer of energy. Temperature, you might know it as just being how hot or cold something is compared to a relative point. But what it actually is doing is it's measuring the average kinetic energy. Now remember, kinetic energy we talked about a few units ago is all about motion. So what it's doing is temperature is showing you how fast those particles are of the substance, how fast those particles are moving around in whatever substance you're taking the temperature in. Whether it's the air or water or something like that, it's telling you how fast those particles are moving. Now, in here, the units for temperature are going to be in degrees Celsius or in kelvins. We're not going to be using Fahrenheit. Okay, the more an object is heated up, the faster the particles move. Okay, so that should make sense because temperature is the kinetic energy. The higher the temperature, the more kinetic energy, and remember, kinetic energy is all about motion. Okay, so now let's talk about thermal energy. Thermal energy is the total potential and kinetic energy of particles in an object. This depends on the temperature, mass, and the phase or state that the object is in. Okay, continuing on with that, temperature increases. As temperature increases, there is a thermal expansion occurs. This means the particles move farther apart from each other. Okay, so as temperature increases, the particles move further away from each other. So you should see that when we talk about solids. Solids are very compact and orderly. Liquids start to get a little bit more spread out, and then gases can go wherever they want. Okay, now as temperature decreases, it's called a contraction. They move closer together. So temperature increase, move further apart. Temperature decrease, move closer together. You can think of this like a bridge. It has braces to allow for the bridge to expand and contract. Same thing as sidewalks. If you don't put those lines in sidewalks like that, then it will cause the sidewalks to crack over time because of that. Okay. Another definition, specific heat. Now, specific heat is the amount of heat, okay, the amount of heat, so the amount of energy going from the hot object to the cold object to raise the temperature of 1 gram by 1 degree Celsius. So how much heat is required to raise the temperature of 1 gram per 1 degree Celsius? Now, the higher the specific heat, the more heat required to raise the temperature. Okay, that means it takes longer to heat or cool up. Now, this is why you have different cooking instructions for different foods, because some food absorbs the heat quick and heats up quicker, and then you've got food that takes an hour or something just to get it ready to eat. So if you look over here, we've got air, aluminum, and so forth. These are the specific heats for these different materials. So if you look at all these different materials, The one that takes the longest is going to be water, because out of all of this, water has a 1 calorie per gram degree Celsius for it to heat up. That's why it takes so long for a pot of water to boil. Okay? This is showing you the same thing I just talked about. Different materials store different amounts of heat energy. So this is showing you the difference between gold and water. Gold will warm up super quick with the same amount of heat, and then water would only go a little bit up. So water takes 30 times longer to heat than gold, meaning it stores about 30 times more calories. Okay, the next topic, after we've gone through all those different definitions, we now need to talk about the types of transfer. Okay, conduction, key word is going to be contact. Conduction means the objects have to be touching for the heat to be transferred. So like a spoon in a bowl of hot soup. The spoon will eventually get warm as well because of the soup touching the hot spoon. Okay, convection is when you have particles in a fluid that can move from one place to another. Most common example of this is a ceiling fan in a convection oven. Radiation is energy is the key word there, transferred by waves, by light moving through space. Most common example of this, sunlight, microwave type things. Okay, now this is just showing you a picture here of all three of them happening. It's a pot of water on top of a campfire. So the campfire itself is not actually really touching the pot of water or anything like that. It's sort of sitting on top. You've got radiation coming off of the campfire, and that radiation heats up the pot of water. Inside that pot of water, you have conduction happening, because eventually the pot itself also gets warm. Your hand gets warm because it's transferring through that pot of water and gets your hand warm. Now in the water itself, if you've ever watched a pot of boiling water, it sort of does this circular motion. Anytime it goes, it rises. The hot water rises, the cold goes down, and so forth. If it has this circular motion going on, that is convection. Okay. Now the next thing you need to make sure you know is the difference between conductors and insulators. So conductors, okay, conductors mean that they conduct thermal energy well. This means that they get warm very quickly if they have some kind of heat source. And then your insulators, they conduct very poorly. So air, wood, and wool, they stop the heat transfer. Okay, conductors, they get warm very quickly. Insulators do not. They stop or they slow down that heat transfer. This is why you use insulators in a house and in coffee mugs and things like that. Okay, the last topic is law of thermodynamics. There are 3 of them. You need to know all 3 of them. First one, energy is conserved. We've talked about this before. The word conserved means that energy cannot be lost or gained. It's not just randomly made up or gotten rid of. Second law, thermal energy can flow from the cold object to the hot object. Okay, you know this in a refrigerator. You put a warm object into the refrigerator, it gets cool. That's because work is being done. The refrigerator has to be plugged in for that to actually happen. You unplug a refrigerator, it's going to go back to how nature goes, from the hot object going to the cold object. Okay, so it can go from cold to hot, but work has to be done. Again, example of that, refrigerator and so forth. The third law is the absolute zero cannot be reached. Absolute zero is 0 kelvins. What they think, it's a theory because it's never happened, is that when it gets down to 0 Kelvin, no particle movement occurs. All motion, even remember your solids are also vibrating. You can't feel them, but they're also vibrating. At 0 Kelvin, they believe that all movement will stop at that temperature.